So today's topic is Prim's algorithm, and Prim's algorithm is very much alike of Kruskal's algorithm, which is minimum spanning tree approach. So just to recall that what is minimum spanning tree? Minimum spanning tree means that we spans all the vertices in a way to create a tree with the minimum weight values. So Prim is how Prim is alike to Kruskal. Kruskal works on the basis of edges and their weights, whereas Prim works on the vertices. So both are same in terms of spanning tree, but the approach is different. So Kruskal works with the help of edges and their weights, whereas Prim works on the basis of vertices. So let's see what is the minimum spanning tree algorithm for Prim. So in Prim we are having three arguments. The very first is G, that is the whole graph. W is the weight of every transition, or you can say that the set of weights, and we need another argument which is basically the root. So why do we need to root at here? Because we need to identify the vertex from where we need to start the algorithm. In Kruskal we always starts with the least weight value. That's why we arrange all the transitions in ascending order from least value towards the highest weight value, and according to that particular sorted list we choose different transitions in order to identify the safe edges. Whereas in Prim we are working with vertices, and through the vertices we evaluate the attached edges and their weights. So in this algorithm, for each value of u, means u are basically your vertices, because u belongs to graph vertices. So there are two different things. One is u dot key, and there is another thing which is u dot infinity, pi. So what are these two things? Pi basically contains the parent name, and what exactly is your key? Key is the minimum priority queue, which is based on the key attribute. So we are having two different attributes for each and every vertex. So let's see how these vertices evaluates with the help of Prim's algorithm. So we are having the same example, and it contains 9 vertices. So here the root vertex is A, and it is up to us. We can start from anywhere, so it is not restricted to start with ascending order or descending order. We can start from anywhere. So we starts with A. What do we need? We need to identify the transitions attached to this A. So there are two transitions. The very first transition is between A and B, the other one is A and H. So we need to identify the weight values. So the weight value between A to B is 4, and the weight value of A to H is 8. So we need to choose that particular vertex edge which contains least value. So we choose A to B path instead of A to H path, because A to H path contains high value if we compare with the value which is on A to B. So here we reach to B. So from B we need to evaluate all the transitions. So there are two transitions starts from B. One is from B to C, the other one is B to H. Again B to C is least in comparison with B to H, so we choose B to C. And from C there are three possibilities: C to I, C to F, and C to D. The least one is 2. We choose 2. From 2 we can move forward, or we can track back to C. So for I the parent value is C, and for C the parent value is B. So from C to I, when we move C to I, we need to see that the next upcoming transitions are smaller than the previous edge weight or not. So here we see that between C to I the value of edge is 2, whereas I to H and I to G the value of weight are greater than 2. One is 7, the other one is 6. So we cannot move from I onwards. So we need to return back to the parent of I, that is C. And how we can remember the parent value? With the help of vertex pi attribute. So pi always contains the parent name. So if I am standing at I vertex, so I dot pi will contain the value of C. So I jumped back to C and then choose the remaining path. So how I can choose the remaining path? Again, I need to compare 7 and 4, which is the least one. I choose the least one. So I choose C to F with the help of 4 weight. So you can see in E that we move from C to F with the help of 4. Again, from F onwards there are 3 possibilities. One is F to G, F to D and F to E. The last weight we calculated was 4. So we need to see whether the upcoming transitions are less than 4 or greater than 4. If we are having any transition which is less than 4, we definitely move from that particular transition. So we need to choose that transition which is less than 4. So 2 is less than 4. So from F we choose F to G instead of F to D or F to E. So in this diagram you can see that we have highlighted F to G. Again, this is 2. So we need to check the remaining upcoming transitions. If these are less than 2, we can select that transition, otherwise we ignore it. So we check that the upcoming transition, one of the transition between G to H contains the weight value of 1, which is less than 2. So we choose the transition G to H, that is 1. It's fine. Okay, done. And from H onwards, all the transitions are greater than 1. So I need to track back to G as the parent of H. Then the next possibility is 6. I cannot choose 6 because it is greater than 2. So I return back again to F. From F I cannot choose 10 or 14 because 10 or 14 are greater than 4. So I jumped back again to C, and then I choose the last remaining transition, which is 7, which is less than 8. So I can choose this value. So we choose 7. So in this diagram, that is H diagram, you can see that C to D is taken and it's highlighted. When we are standing at D, there are 2 possibilities. Either we go to E with the help of 9 weight transition, or we jumped from D to F with 14 weight transition. So we need to choose the least one. The least is 9, and here the Prim's algorithm stops because it ends and it completes all the vertices. Prim works on vertices, so the iteration will not be more than 9 vertex based. So whenever all the vertices are hit by the algorithm, means all the vertices are selected and the algorithm should stop. So in minimum spanning tree we can either choose weight based transition approach with the help of Kruskal, or we can choose vertex based edge detection with the help of Prim's technique. So thank you very much